All right, folks, in this video, I'm going to show you how to perform my hypothesis test around proportions. So this is a little different than our hypothesis test when we're concerned about the X bar or the mean of a population and a couple of different aspects, and I'll cover those as I go. So this is the problem that we're going to be doing today. Harris poll surveyed 2016 adults and found that of those, 423 of them had one or more tattoos. You conclude that the percentage of adults who have a tattoo is less than 25%. Use an alpha equals 0.01 level of significance. So I start to pull out the very important parts of this problem as I'm going through it. So a Harris poll surveyed 2016 adults. So I know that my number surveyed is equal to 2016. My number of yeses, if I will, in that survey is 423. And I know that working with proportions previously that my p hat for this proportion is going to be 423 divided by 2016. I'm going to let my calculator calculate that. I'm not sure exactly what that is. What else can I pull out of this? Can you conclude that the percentage of adults who have tattoos is less than 25%? Okay, well, that tells me which hypothesis tail I'm going to do. I always know my null hypothesis for proportions is P equals whatever is the status quo, the thing that is boring that we want to disprove is 0.25%. My alternative here is P is either going to be less than, greater than, or not equal to 25%. Not, what I notice is that it says is less than 25%. So they are asking me for a left-tailed test. How can I tell it's left-tailed? Look at the little, look at the little arrow, and I notice that the arrow, the less than symbol, is pointing to the left. That is my easy way to tell whether it's a left-tailed, right-tailed. Two-tailed is just not equal to, okay? So now I have everything at my disposal. I'm going to write one more thing here. My alpha equals 0.01. I have everything at my disposal to determine whether or not I'm going to accept or reject, or I'm going to reject or fail to reject the null hypothesis. Remember, we never accept the null hypothesis. Now I'm going to move over to my calculator. I've written one more thing up here. This is my test statistic for this operation. Remember, this test statistic follows a standard normal distribution around 0 and 1. So that means my mu is equal to 0 and my sigma is equal to 1. We're going to use the norm.des function. For the other hypothesis test, we're using the student t distribution. Okay. So now I'm going to go over to my calculator. I'm going to try to keep most of these windows up as much as I can, but limited on space. Let me make this just a little bit smaller. Okay, and I'm going to make myself a nice template. Templates are always a good way to go whenever you're doing these type of problems. What do I need in this template? I need P naught, right? That's the thing that we're testing against. I need X, I need N, and I need P hat. Let me stop there and go ahead and fill in some of these things. My P naught here is 0.25. My X here is the trues I've seen out of my population, 423 and 2016. My p hat is going to be this x divided by n. So I'm going to go ahead and calculate this. The x divided by n. I'm going to keep everything in formulas mode until we get further on. I'm not really concerned with the actual numbers until we get to the end of the problem. Okay. I also, when I set my templates up, I like to highlight in yellow the things that I have to put in. Everything else that's calculated, I let stay the white. All right, so now I have everything I need to calculate the test statistic. The test statistic for this is a little more complicated, so I usually break it into a numerator, denominator. So test stat numerator, test stat denominator, and then the final test stat is going to be the numerator divided by the denominator. I can even put this in here. Excel's not going to like this, but I can put this divided by this, oops, this divided by this, B4 divided by B6. I'm going to get an error here, and that's okay. See this little green dash? I'm in formulas mode, but you would see it as an error That's okay. As soon as I fill in all the other values, this will actually be a value. Okay. All right, so the numerator here is my p hat minus p naught. So this is my p hat minus p naught. Now, since this is a left-tailed test, I'm hoping that this is well, the test statistics should be a negative number. So let's go ahead and finish with everything before we look at any of the numbers. The denominator, I'm going to use the square root function, SQRT, and then I'm going to multiply p naught times 1 minus p naught divided by n. N is right here. N has not changed. Let's take a look at our numbers real quick before we go further. Okay, great. My test statistic is negative. This is good. It's a left-tailed test. Now, if I was to draw the picture of what we're going to find what our p-value is going to equate to here, my test statistic is way over here at negative 4.166. I know that this is a normal distribution around 0 and 1. And my p-value is this area under the curve into infinity. So let's go ahead and calculate that p-value. That's going to be what we're going to compare against that alpha to determine whether or not we can accept or reject we can reject or fails or reject the null hypothesis. P-value equals norm.dist. Thankfully, this is a left-tailed test. I don't have to do 1 minus. I don't have to do any fancy mathematics. But always remember, Excel takes the area under the curve from the left to whatever number you're getting to. Okay, so here's my test statistic. My mean is going to be 0. My standard deviation is 1. Cumulative is always true. Okay, always true, not true 0. Okay, that is a extremely small p-value. At any alpha, I'm probably going to reject the null hypothesis. So our conclusion here is to reject the null hypothesis and state that fewer than 25% of adults do have a tattoo. Thank you. Make yourself a template. Help you out.